Hi, this is Mridula and this is my Physics 2212 Lab 2 video, Lines of Charge. The purpose of this lab video is to compare the point charge model to the lines of charge model, to divide the tape into segments and treat each as a point charge to approximate an accurate charge quantity on each tape. A preview of the main results are the point charge on each piece of tape was found to be 1.26 times 10 to the power negative 8 coulomb from lab 1, and the lines of charge on each piece of tape is 2.5 times 10 to the power negative 8 coulomb. The principles used in this lab video, are Newton's second law of motion, which states that the rate of change of momentum of a body over time is directly proportional to the force applied. So F is equal to ma, which is equal to dp by dt. Coulomb's law, which describes the strength of force of attraction or repulsion between two charged particles. So Fe is equal to k times q1 times q2 divided by r squared times r hat, where q1 and q2 are the two charges, and r is the distance between the charges, and gravitational force, which is the attractive force between two objects with mass. So F is equal to g times m1 times m2 divided by r squared, and the g is negative, where g is the gravitational constant, m1 and m2 are the two objects with masses, and r is the distance between the two objects. Next are the initial conditions / the lab 1 results. So the system is tape B, surroundings is tape A, and everything else. Mass of the tape is 2 times 10 to the power negative 4 kg. Length is 0.2 meter. Width is 0.02 meter. Distance between the tapes is 0.027 meter, and the charge on each piece of tape, the point charge, is 1.26 times 10 to the power negative 8 coulomb. The procedure for this experiment is the same as lab 1. So after the charge on tape B was determined, it was hung on the ends of an object, and tape A was brought close. So tape B began to float due to the repulsion of positive charges on both the tapes, and the distance between the tapes were measured. The magnitude of Fg is equal to mass times gravity, which is 1.96 times 10 to the power negative 3 newtons, and the magnitude of electric force is equal to the magnitude of gravitational force, as the acceleration is 0. And for the force of an electric charge formula, the electric field of a rod is used, as the bottom tape is divided into segments of point charge which act like rods. So F is equal to kq divided by r times square root of r squared plus L by 2 squared times q, where r is the distance between the two tapes and L is the length of the tape. So I isolated for q, and I found that the lines of charge on each piece of tape is 2.5 times 10 to the power negative 8 coulomb. These are the initial conditions for the computational model, which was also talked about in the experiment. So here the lines of charge q was found to be 2.5 times 10 to the power negative 8. The first function is used to calculate the electric field, and the second function is used to find the line charge. So in the second function, I'm taking a piece of tape and dividing it into n segments. So n here is 50, and each segment represents a point charge with a specific amount of charge and mass. So this is used to calculate the electric field on the top piece of tape. So in this part of the code, I'm trying to find the electric force from each point charge, and since there's so many point charges, a nested for loop is used, and to calculate the total electric force on the top tape by the bottom tape. This is the result of the computational model. The white arrow is the electric force, the green part is the electric field, the red line is the top tape, the blue line is the bottom tape, and the yellow arrow is the gravitational force. And the magnitude of electric force and gravitational force were also calculated. The assumptions made are air resistance and friction are negligible. Each piece of tape has the same amount of charge, which is uniformly distributed on the tape. The possible errors are inaccurate measurements like the tape length, tape width, or separation distance, and loss of charge due to handling or the environment. Finally is the discussion. In question 1, the point charge on each piece of tape is 1.26 times 10 to the power negative 8 coulomb found in lab 1, and in lab 2, the lines of charge on each piece of tape is 2.5 times 10 to the power negative 8 coulomb, which is almost double of the value of the point charge found in lab 1. So the reason for this is talked about in question 2. So in question 2, these estimates differ due to different levels of precision in the calculations. In the lab 2 calculations, the formula for the electric field of a rod was used. The lines of charge model is closer to the real value as it uses segments of the point charge along the length of the tape, whereas the point charge model generalizes the entire tape length as a single charge. Thank you.